But I think a lot of this goes back to, earlier Kate was saying that, we want to base this more on facts and less on opinion. Um, and so like part of like software being developed is it goes through multiple levels of transformation. So whether it's writing source code to binaries, taking binaries, packaging them into a container, into a virtual machine, and so on. There's a lot of things. There's a lot of processes that go on in the creation of software. And the more accurately we can represent these processes and document them, the more factual information we have to then evaluate the ecosystem and to kind of evaluate the claims that we have. So the build profile goes around a couple of use cases. The first is security. We know about vulnerabilities. Rose and Adolfo talked a little bit about that. But we're in an age where we also have supply chain compromises. A build system gets compromised, a build tool ends up spitting out bad output. In those cases, we do also have to figure out when something like that happens, how do we go about remediating it? I know we have folks from the reproducible builds here as well, and that's also part of like ensuring a good build is one is like we can understand the provenance of a build, but at the same time if we are able to reproduce the build and multiple people can independently verify them against each other, then we get that guarantees as well. And so a lot of this is also like kind of borrowing and lending from a lot of the supply chain and build provenance side of things. So we took a lot of inspiration from Salsa. We took a lot of inspiration from reproducible builds when we started creating this. Also auditing the quality and pedigree of the build. So this goes in a case where like initially when we're giving an SBOM, we say here are the components of a particular piece of software. Now I'm saying that this contains Carol's compression library, but then the question is how do I know that this contains Carol's compression library? And in this case, if we have the build information propagated with provenance, we can say that, yeah, this is how I figured out the information, and that kind of assurance and certainty of my claim then becomes stronger. And last but not least is in the area of safety, where we are dealing with human lives and like critical infrastructure. We need to be able to reason about what goes into the software, and having that level of granularity is very important. So I'm going to pass it to Nisha to talk about a few examples.
Okay, so we have a couple of examples that we worked on. One of them is the hosted build paradigm. So for example, GitHub Actions. So if you were a software developer developing like a Python application, you may be able to use a GitHub action to generate a wheel and publish it to PyPy. I'll see if I can use the clicker. So if you think about the case of GitHub Actions doing a build, the instance of that build is what the build element is made of, and that is the primary class that we're using in the build profile. This information that's in the build element, you should be able to generate that from the build stage that you're using. So GitHub Actions already generates all of this information. And so when you are making a build profile, you should be able to encode all of this information. So this is things like the build ID, start time, end time, the parameters that went into your build, what configuration you use. So typically for GitHub Actions, you would have a .github and workflow for a build that happens on GitHub Actions. So you can use that URL over there. You can figure out what the what commit that build was done on, and so you can encode that information in here, and then you can also point to any log files that you find. Now, that's not enough for us to glean like what exactly happened in the build, because things we want to know is like what file was used to configure the build, and we want to know like who configured the build, and all of those connections we use the SPDX relationships. So we've added a bunch of SPDX relationships to the core model to encode those kind of relationships between the actors in the build, what the source code is that went into the build, and what parameters went into the build with the build tool. So you have a number of things in here that define, for example, all of the pink stuff are all packages that are representing the build tool that was used to invoke the build. The green one on the top is used to represent what the host was on which the build was invoked. So what VM you're using or what container you're using. You have like the teal ones, which are the orange one, which is the build configuration. So this is like any of the YAML files or setup.py that you would use to define what you're going to build. And then there are some purple things over there, which is using the core's identity. And that is used to define, like, to identify who or what triggered the build. So the second example we try to use is something like a build system that you would host. You would either host or you would install on your own machine and invoke the build. So this is, it's almost like the self-hosted environment or the on-prem environment that an organization may set up to do their builds. So in this case, you would still be using a build element, but there are also like more introspection that you can do. So for example, the build that gets triggered by an event may spin up some parallel builds. And so we introduced the concept called a nested build. And so what you can do is, if you wanted to introspect your build some more, you could define that, okay, if I do make, for example, that will trigger off a compilation of source code or setup of build scripts or downloading of build scripts, and each one of those can be a separate build stage. So in the nested example, you'll have each one of those build stages as build elements. And each of them will be able to encode like the build element parameters. So this is the top level build that you would define, and there will be a nested build that happens that gets triggered after this, and that's, you can have a relationship called build child of that points to the build that triggered off the secondary build.
Yeah, I think one of the things that I think when we kept in mind when building this, a lot of the discussion was around like how to implement this. And I think the idea is like, if you look at GitHub Actions, if you look at things like Circle CI, Tecton build, and everything, it's like kind of different levels of granularity, and there's a little bit of mismatch between like sometimes of like what the build system can instrument and what is required. And so I think like as Nisha went through the examples, a lot of this for what we're showing is that you can actually like incrementally build this. So as a build system, you can say, okay, I have this nested builds. At some point, I can say, I have a few more nested builds, but I don't know any information about that. And so I can be like, no assertion. And as the build system is able to have better instrumentation, they can then start building out the capabilities.
Yeah, and so this is why we encoded those additional information as relationships, because there are situations where you can introspect some of the build, but you can't introspect all of it unless you do more investigation. And so once you get more information about what your your build looks like, then you can add on to the existing SBOM that you'd created. So this looks like the same thing, right?
Yeah. So this is just a final slide just to show like what you've seen, but this is actually like just the elements of the build model. So I think the main things to kind of show off is like just making a distinction. I know we kind of baked this already into relationships. This is a few weeks out of date. But basically defining inputs, outputs, we built around the model, around the like who, when, where, why type of questions of the build. And so like, if you're creating a build system and this is like the intention of the build profile is mainly for builders or build tools, these are kind of things that you have to keep in mind, right? I think it's the questions of like, what goes into the inputs, outputs, the actors that are defined in that, and being able to then decompose this into nested builds. Yeah, I think Nisha, in her examples, like gave a good overview on how that would be implemented. I think that's all we have for the build profile.
Okay.
Hi, thank you. Do you have an example of how that's represented in an SBOM?
We don't have a serialized version of this yet. Actually, right now, we're trying to figure out how to incorporate the relationships, because that's where this profile shines, because you want those relationships. So right now, we have the relationships in the core model, but we need to discuss how we can put some constraints around it, meaning like if you're using the build profile, then you have to use these mandatory relationships. But as far as serialization goes, we don't have an example of it right now, but we're working on it.
No, you hit that. I was more interested in the relationships and how those would be represented in even a sample existing SBOM, which gives us an idea of what it looks like.
So in SPDX 3.0, relationship is a core element. And so what you would do is just create an element that has the from part, which is represented by the IDs, the from part, the to part, and then the relationship type. And the relationship type is what all these are, the build input of, build child of. So once you figure out, okay, that's what my build graph looks like, you can create an SBOM with the build profile in it.
So I think just to illustrate a little bit, right? I think this thing, if you didn't have the build profile, I think what it looked like is you had an input, which is like the build, basically the build input file, and then you will have the package as output. So in your traditional, however you want to call it, but like in a bill of materials today that just describes the content, you would say like this package is using the generated, or this file generates this, right? And so what the build profile is kind of like an overlay upon those elements to show you like, okay, this is how the sausage is made. Yeah.
Okay, thank you. I have one question. These informations are very useful for understanding the, when we build some packages. But recently, these informations are getting more complex and complex. So from my understanding, SPDX and SBOMs are for security and license compliance. So my question is, do you have any vision or idea how detailed information should be treated and created in the fitting in the SBOM?
Okay. So the thing about SPDX is you represent what you need. If you need to go down to the level and the detailed level for something like a safety use case, you can, but you don't need to. You only can represent what you have available to you, but if you want to go back and refine it further and put a lot more information about your builds, there's a way to do it. It's very scalable. That's the whole idea here.
I think each profile has a mandatory field. So when we'd like to use some certain profile, we need to implement the mandatory field.
Right.
Right? Okay.
In fact, that's a great, oh, I can talk through the microphone. That's a great lead-in for what we're going to talk about next, which is the migration from SPDX 2.3 to 3.0, and profiles and relationships both are topics for that. So
we've got a last question here.
Oh, go ahead.
Hi. I've read something about Omnibor that seems to be do a graph of everything that was done in the build. Does it connect to this? Do you plan on?
Yeah. So we currently have the ability. Is this on?
Yeah, it is.
We currently have the ability to encode like gadoids, which is what Omnibor uses as hashes. The idea is that with that relationship within that, you would be able to kind of overlay this information to kind of describe, take that Omnibor DAG and then be able to translate it to like this was how it was built. This is the composition of it. And through those relationships and those hashes to be able to kind of directly map the inputs and outputs more accurately. And
so the beauty of Omnibor is that all of the information comes out from the build system. A lot of the times when we are building a software, we don't actually know what the interactions are. Like we don't really see anything that's statically compiled. We just guess based on, okay, we gave this thing these kind of C flags, so I'm going to guess that that's what happened, but we don't really know if it actually happens. So it's more like, yes, you can use this to encode whatever information you know, or you need to know, or whatever you need to encode. But with Omnibor, it becomes more accurate.
Right. So my idea is you can encode the whole Omnibor report into a build profile. Like that's the
or parts of it, because we still have external references. So you can just encode the top part of it and point to an Omnibor graph.